Welcome to this party. Mr. Sutton here, bringing you the Pre-Cal Honors 3-7 Part 2 homework solutions on graphing rational functions. For this problem, they gave us a bunch of information about a graph and they want us to sketch it. Now, although they gave us a decent amount of information here, a lot of it was non-information, right? Look at all these nones here. So we've got no x-intercept, no y-intercept. So already that's no points to work with in graphing this thing out. We do have a vertical asymptote at x equals 0, so that's the y-axis. We can draw that in there. It's just a dashed line, although you can't really see it because it's on the y-axis. We also have a slant asymptote at y equals 2x. So starting at the origin, because that's the y-intercept of the line y equals 2x, we go up 1 over 2 and keep doing that and draw a slanted line going through those points. So this is good. The trouble is we don't know where I'm drawing the branches of my rational function. Is it over here? Is it kind of in these corners? Is it over here? We don't know. So to figure that out, we're going to have to plug in some points on either side of our vertical asymptote. So let me start with the point -1. If I plug in -1 to the original function, let's see what that gives me. And actually let me do +1 first. That's even easier. So we'll start with +1. We've got 1 squared times 2 is 2, plus 1 is 3. That's 3 over 1, which is 3. Great. And before I put that point on there, let me just get another point on the left side. For this, I will use -1. So we've got -1 squared is still +1, times 2 is 2, plus 1 is 3. So we have 3 over -1, which is -3. So I've got the points 1, 3, which is up here. And I have also -1, -3 down here. Now I've got enough information to draw my graph. So they're going to go through these dots here, these points, and approach but not cross the asymptote. So we've got a branch down here going kind of like this, hugging the asymptotes, going through that point, and another graph branch that kind of looks the same, just sort of reflected over the origin, up here doing a similar sort of dance. For this problem, we're going to go ahead and sketch this function they gave us in both its original and its simplified form, and they also gave us a bunch of attributes to go with. So let's start with the x-intercept. We'll put a dot on 0. That also happens to be the y-intercept, so that extra piece of information didn't really help us, but we're not going to complain. The vertical asymptote at x equals 2 is going to be graphed right here. It's just a vertical line, dashed line that the graph approaches but does not cross. We have a hole at -3. We're going to put that on the graph after we've actually graphed out the different branches of this thing and we see where the graph is. Otherwise, we're going to have to figure out the y value that goes with this, and it's faster just to wait till the graph is already there. We have a horizontal asymptote at y equals 1. So that's a horizontal dashed line going through 1 there. And now taking a look at the information I have, I've got a point on the left side of this vertical asymptote, so I can draw a branch here in a minute. But on the right side, I'm not really sure where to draw my branch. I need to know if I have a point above or below this horizontal asymptote. So let me go ahead and get an additional point. I'm going to take the x value 3, because that's to the right of this vertical asymptote, and I'm going to plug 3 into the simplified formula. So you have to be careful doing this, but the hole that they identified is at -3, so I can plug anything else I want into the simplified formula, and I'll be fine. So we've got 3, and this is again for our additional points here. We've got 3 over 3 minus 2. That's 3 over 1, which is just 3. So we've got the point 3, 3 right here that our graph has to go through. So let me draw the branch on the left side now that goes through the origin here and approaches but does not cross the asymptotes, like so. And now let me draw another branch going through this point and approaching the asymptotes. And we can't forget we have this hole at -3, so let's go back and see where -3 is. So on the graph at -3, we'll put an open dot right there. On this problem, they want us to find all the intercepts and asymptotes and then sketch the graph. So I can't really reduce or simplify this at all. I'm just going to dive right into finding those different features. We'll start with the x-intercepts. For that, I need to make my numerator of x squared plus 1 equals 0, so I can zero out the whole fraction. Unfortunately, if I subtract 1 and I square root, I'm taking the square root of a negative number. I'm going to get imaginary numbers, which cannot be x-intercepts because they have to be on the real x and y axis. So we have no x-intercepts because of that. For y-intercepts, I'm going to plug 0 into the function everywhere. So we've got negative 0 squared plus 1 over 0 plus 2. And that's going to give me, let's see here, we've got a 1 over a 2. And the whole fraction is negative, so that's negative 1/2. So we'll put that on there in a moment. For vertical asymptotes, I need to set the denominator, x plus 2, equal to 0, and see what makes this thing undefined. So that's going to be x equals negative 2. There's no holes, since there's no common factors that got canceled out, so we don't have to worry about holes. For horizontal asymptotes, I see that I have a top-heavy function. We have an x squared in the numerator versus only an x to the first power in the denominator. Since we are top-heavy, there's no horizontal asymptote. There is, however, a slant asymptote that we can find. Since we have a binomial that we're dividing by here, we're going to use synthetic division and divide the numerator by the denominator. So we've got, let's see here, I'm going to consider this negative to be part of the numerator here. So listen closely. I'm basically going to distribute this negative before I do synthetic division. So I'm going to think of this as negative x squared minus 1. With that in mind, my first coefficient is negative 1. We have a 0 placeholder for the x, so all sorts of trickery going on here. And we have a negative 1 as my next coefficient because, again, I distributed this negative to both things in the numerator. Now I have a box number of whatever zeroes out the divisor. So in this case, that's going to be negative 2 because negative 2 plus 2 is 0. So negative 2 in there. Bring down the 1, negative 1 rather, times negative 2 is 2, plus 0 is 2, times negative 2 is negative 4, and it doesn't really matter at this point with the remainder, but it's negative 5 over there. So now looking at my coefficients, this is going to be negative 1x plus 2, and y equals that is going to be my slant asymptote. Okay, so I did a whole bunch of work. It's time to put it all on the graph now. So no x-intercepts to worry about. Y-intercepts, we have a negative 1/2. So that's going to be, let's see, these grid lines are going by 2. So that's going to be like a quarter grid line right about there. We also have a vertical asymptote at negative 2. So that's right about here. And we also have a slant asymptote of y equals negative x plus 2. So starting at a y-intercept of 2, we're going down 1, right 1, down 1, right 1. So something like this. We've almost got what we need to graph all of this. We definitely have a branch going on in this kind of middle bottom sort of place. However, we don't know if we're doing another branch above or below the slant asymptote on the left side of that vertical asymptote. So to figure this out, we're going to plug in an additional point. I'm thinking, well, let's see here. This is negative 2 right here. So if I did negative 3 or negative 4, that would do the job. Let me plug in negative 3 to my original function and see what we get back as a y value. So we've got negative 3 squared is 9 plus 1 is 10. Down here, negative 3 plus 2 is negative 1. We have a negative outside here, though, so negative 10 is going to come out to positive 10 when the dust settles on this one. So I have the point negative 3, comma 10, here's 6, 8, 10 up here. And now I have enough to graph this whole thing. So we've got a branch going through this point and approaching but not touching those asymptotes in the upper left there. And then we have another branch down here going through this point, approaching but not touching the asymptotes. And this is about it. Just taking one more quick look. There's no holes to put on after the fact, so this one's all set. For this problem, they want us to figure out all the intercepts and asymptotes, and holes also, and then sketch the graph. So we see right away here that we can actually cancel out the x plus 2s. It was already factored for us, which is kind of nice. So now that'll help me out. Finding the x-intercepts, let's start there. I have to set the numerator equal to 0, but the numerator, all that's left over here is a 1. Since there's nothing left but a 1 in the numerator, there's no x in the numerator, we can't actually zero out the fraction, so we don't have any x-intercepts. Moving on to the y-intercepts, if I plug 0 into all of these, and I actually could just plug 0 into this reduced version here. So I'll have 1 over 0 plus 3 quantity squared, which is just going to be 1 over 9. So that's our y-intercept that we'll put on there in a moment. What else do we have? Vertical asymptotes. So we're going to take x plus 3 squared and set that equal to 0 because I'm trying to zero out the denominator. So anything that's left after simplifying in the denominator, we set it equal to 0 and solve. And I see that if I plug in negative 3 for x, that'll zero that out. So that's where my vertical asymptote is. For holes, I take a look at things that would have given me undefined in the original, but in the simplified not so much. So this canceled out factor of x plus 2. For the hole, if I set x plus 2 equal to 0 and solve, we get x equals negative 2. That's the x value where our hole is going to happen. And then finally, horizontal asymptotes. Taking a look here, I've got first degree up top. Down below, I've got, if I multiply all these out, third degree, x to the third power. This is a bottom-heavy function, so we automatically have a horizontal asymptote at y equals 0. All right, let's go ahead and graph all this out. So again, no x-intercepts to worry about. Y-intercept at 1/9, so that's right here just above the x-axis. We have a vertical asymptote at negative 3, so that's a vertical line back here at negative 3. The hole we're going to have to take care of a little bit later after we see where the graph is. The horizontal asymptote at y equals 0, we can draw that, although it's basically the x-axis, so you don't really have to draw it if you don't want to. And we don't quite have enough information yet to graph this thing. We need to get an additional point somewhere on the left of this vertical asymptote so that we know if we're above or below the horizontal asymptote. So I'm thinking the x value, negative 4, would work out very well. That's just to the left there. So if I plug negative 4 into this function, and when I plug in negative 4 for the additional points, I'm going to use the simplified function, so 1 over negative 4 plus 3 squared. Let's see here. That's really negative 1 squared down there, which is just 1. So this whole thing comes out to 1. So we have the point negative 4, comma 1 right there. All right, so let's go ahead and draw a branch that goes through this point and approaches but does not cross the asymptotes there. So something like this. And then over here on the right side, since we're above the x-axis, we have to come down like this, go through that point, and then approach the horizontal asymptote as we move to the far right. And there's our graph. There's just one more detail to take care of. Remember, we had a hole that we found at negative 2, the x value. So going over here to negative 2, we'll just draw a hole in wherever the graph is right there.